Good morning to everyone. My name is Lau Yong Pin. I am from Group 14. Today, I would like to present topic about postfix notation. And here are the team members of Group 14. The first one, Chia Min Jeng. The second one, Chun Ming. The third one, Teo Yong Jun. And last one, me, Lau Yong Pin. Below are the student ID for us. So before we start, I would like to give some introduction to postfix notation. Postfix notation, also known as reverse Polish notation (RPN), is mathematical notation in which operators are placed after their operands. In other words, the operands are listed first followed by the operator. Postfix notation are very useful in computer science because it can be easily evaluated by a computer program. Programming language and compilers also use postfix notation as an intermediate representation of programs during compilation and optimization. And here are some examples of postfix notation. The first one, D divide E. D and E is the operands and divide is the operator. So what we need to do is we move the operator between the two operands to the back. For example, we move the operators divide to the back and it will become like this. D, E, divide, and it is settled. So let's see about the example 2. Example 2 has the same solution with example 1. We just need to move the operator to the back. So the answer will be A, B, add, and it's settled too. So let's see the example 3. Example 3 has a little bit difficult than the question example 1 and example 2. So before we start, we see some tips about this. Perform multiplication and division from left to right before addition and subtraction. It means that the addition at here, it will be the last part that we do, the last step. We will do multiplication and division first, and two of these has the same equal priority, so we will start from left. So it will become BG multiply, and this will be the same, just copy. The step 2, after we settle BG multiply, and we will do this hash k divide, we move to the back. After this, left this addition, so we will do like this: BG multiply hash k divide add. The addition we move to the back and it will become like this, settled. So let's see the example 4. C minus E multiply F add G. Because they have the bracket, so we need to settle this first. And in the bracket, multiply is have higher priority than the subtraction. So we do the multiplication first. EF multiply, we move to the back. After this, C minus, and we move the operator subtraction to the back. So it will become CEF multiply minus plus G. This one just copy. After we change the operand to postfix, we can delete the bracket. So this will don't need the bracket anymore. So the last step, plus addition and G. We move the addition in the back to the back. CEF multiply subtraction G addition. So the answer will be like this. So we have learned the basic of how to convert the program execution to postfix notation. Now I am going to explain the example from my group's assignment. So this is the program execution from my group. X equal to V add the square bracket and bracket hash add D divide G subtract I multiply square bracket C multiply bracket E add A subtract F and subtract bracket J divide B. So what we need to do, we should know the priority. the square bracket has the higher probability at here, and it have two square brackets, so we need to do from the left. From the left, we have the bracket, and this is divide, so we should do the first. D divide G, so we need to move the operator to the back between two operands. So it will become D, G divide. And the rest, we should copy from the above. And the step 2, since we have done this, so we will continue to do the inside the bracket, the hash add. So this is the one operand and this is the one operand. So we move the operator to the back, so it will become hash D G divide add. After this, on the left, we should do the same thing, copy from the above. And the next step, we have done this, so we should do this. Operands and operand, so move the operator to the back. It will become hash D G divide add I subtract, and the rest send copy. And the step 4, since we have done this, and we should do this because it has square bracket and EA is the bracket, so we should do the ES first. E add A, so we move E add A. And since we have convert to postfix notation, we can delete the bracket. It doesn't need anymore. So it will become like this. And the next step, this one, multiply has the higher probability than the subtraction. So we should do the multiply first. C, E, A, add, multiply. The rest copy. After that, we have done this, so we should know this is inside the square bracket. We still have the subtract and F, so move the operator to the back. C, E, A, add, multiply, F, subtract. And this will be the same if we have convert to postfix notation. We can delete the bracket. It doesn't need anymore. And the next step, we have done this, and we should see where is the highest probability now. N is the J divide B because it has the bracket, so we should do this first. Move the operator to the back, so it will become this JB divide. And the rest, this we should just copy. After this has done, we should see what is the less that has higher probability. So it's the multiply. Multiply has a higher probability than subtract and the add. So we should move the operator to the back between two operands. So this one will move to here. So it will become this hash DG divide add I subtract C E add multiply F subtract multiply. So the rest, this one subtract and this V add, we should just copy. So it will become like this. And the last second two steps, we have left V and add, so and this one subtraction. So two of these has the same probability. So we should start from the left. We should do this first. So move the operator between two operands. This is the one and this is the one. Move to the back. So it will become V hash DG divide add I subtract CEA add multiply F subtract multiply add. This X is from here. And this we should just left it. And the last step, we left this subtraction only. So do the same thing, move to the back. So the last step will become VHDG divide add I subtract CEA add multiply F subtract multiply add JB divide subtract. This will move to the back. So it is done. So it is the end of my presentation. Thank you.
Hi, my name is Ming Jeng. I'm happy to be here today for this presentation. Today, we will be diving into a rather interesting topic, which is the state diagram within program execution expression. A state is a linear data structure where insertions and deletions are only allowed at one end, known as the top of the stack. If you are unfamiliar with the concept of stack, you can just think of them like a stack of flags. When you add a flag, it goes on top, and when you take on, you take it from the top. The most recent flag you put at the top is the first one to be removed. This last in first out principle is fundamental in areas like expression evaluation. In program execution expression, a state diagram is used to visualize the state of stack during expression evaluation. Now, let's move on to our demonstration. Our case study today is a program execution expression that designed by our group. My teammate Yong Jun has done an excellent job by converting this infix expression to postfix notation, which will guide us in drawing our stack diagram. We begin by pushing V onto the stack, like placing a flag at the bottom. Then step 2, we push hash. Step 3, we push D. And step 4, we push G, each one on top of the other. Then step 5, we divide D by G by taking two flags off the top, combining them and putting the result back. Step 6, we add hash to the result of the division again, like taking the top two flags, combining them and putting the result back and on top. Step 7, we push I onto the stack. And then step 8, we subtract I from the previous result. Then step 9, we push C. Step 10, we push E. And step 11, we push A. Step 12, we add E and A together. Step 13, we multiply the result by C. Step 14, we push F and then subtract F. Step 16, we multiply the two results on top of the stack. Step 17, we add this result to V. Next, we push J. And step 19, we push B. Step 20, we divide J by B. And step 21, we subtract the result from our current top stack. Finally, step 22, we pop the result into X, like taking the top flag off the stack and giving it to X. By the end of these 22 steps, our final state diagram shows value of the X based on our postfix expression evaluation. Thank you for your attention. I hope this presentation gave you a more clearer understanding of how state diagram operate within program execution expressions. Thank you once again, and please feel free to ask me any question. Bye.